We are discussing the making of the clock for Nadi, Vinadi and Prana. In the first part, we spoke about the gear ratio calculations. Now it's time to design gears using FreeCAD. In this, we will use spreadsheet workbench to create spreadsheets within FreeCAD. We can refer these variables in all the parts we design. This is good for consistency as well as future changes if any. For example, it could be axle diameter or thickness of the gear we want to change. All gears will be of module 1.5 for this project and thickness of each gear will be 4 mm. For compound gears, smaller gear will be of 6 mm thickness. That leaves a gap of 2 mm height-wise when gears are meshed. For all the gears, 3 mm SS rod will act as an axle. Adding 0.4 mm to this value is good enough for holes in the gears to rotate around the rod. To ensure that gears rotate without wobbling, let us add some height without the teeth. Right now, our clock will be driven by a motor, so let us provision for its location as well. Let's create LSS by clicking here. This will enable us to refer these values while creation of parts. Let us create our first compound gear. We'll open the part design workbench, create a part and body. We'll name this gear as G_30_10, meaning compound gear with 30 and 10 teeth. The same convention will follow for the rest of the project. Let's select Create Involute Gear from the menu and add values. Here, we will change only two values, module and number of teeth, that is 1.5 and 30. Same for the second gear, 1.5 and 10. Let us add hole for the axle and provide some height. This sketch has to be moved 10 mm in the Z direction. Our base gear is ready. We'll introduce some holes in between to make this gear lighter. For this, polar pattern can be used to create 6 holes from this one hole. Finally, let us add fillet to the axle hole. That way, it will not be holding the axle tightly when 3D printed. Our first gear is ready to print. We will create remaining compound gears similar to this one. Now that we have compound gears in place, let us take up gears which will drive the Nadi Vinadi hands or pointers. This gear will be used by the green pointer. For this gear, aluminum pipe will be used as an axle. ID of this aluminum pipe is 6 mm and OD of 8 mm. This pipe will act as an axle for the next gear which will drive the Vinadi pointer. This second gear for the axle will be used by shining or Vinadi pointer. We will keep its ID as 8.4 mm so that it can rotate freely with an axle of OD 8 mm. OD for this particular pipe will be 13 mm. Our last axle gear will host the Nadi pointer. Its ID will be 13.5 mm, just 0.5 mm more than the OD of the earlier one. OD for this particular pipe will be 17 mm. With all the compound gears in place, the only gear which remains to be created is the one for the motor. This gear has 20 teeth. Here we have 8 gears of different types for the clock. Now it's time to design housing for these gears so that we can perfectly mesh these gears together. That will be covered in the next video. Thank you.